Assalamualaikum and good morning, everyone. Okay, so for today, we will discuss six before we continue with our next lecture. All right, so for quiz 5B, the transformation theta L over T, okay? So before we can find the transfer function, first we need to do some impedance transfer, and we draw the system to a system without any gears. So firstly, what we can do is it's easier if you can transfer less things, okay? Transfer less impedance. So to transfer less impedance, it's wiser or easier to transfer everything to the middle section. Okay, so first we transfer the spring here. When we transfer the spring to this section, then it will create another spring connected here, okay? You cannot add this spring with this spring here because it will then eliminate this degree of freedom here. So let's assume there's a degree of freedom theta 1 on this shaft. And on this shaft, we have theta L given already. So when we transfer this damper to this section, then you cannot add with this one, but you need to introduce another damper over here. So the system can be reduced in this form. Okay, so this one will be your 2 Newton meter per radian, and this damper is 3 Newton meter second per radian. So there is a degree of freedom in the middle. So let's put theta 2, and this is theta 1 and theta 3. Okay, so first we determine this one J1, and then we determine D1 here. Okay, so J1 is equals 1 over 10 times n destination over n source squared. So you get 200 over 10 . So you get 40 Newton meter radian. And then for D1, it will be 200 times n3 over n4 squared. So it becomes 2 Newton meter second per radian. Okay, so if you have this value, you get 1 mark, and this one also 1 mark. And redraw the system, another 1 mark here. And then you need to transfer the torque. So the torque here, let's say we call it T1. So T1 will be T times N2 over N1, and theta 3. So theta 3 is equals 100 over 10 theta L. So you get 10 theta L. And this one you get 100 up. You get 20 T. Ayo, what is this? Okay, so after that, you can draw the free body diagram for each of the degree of freedom. So we start with theta 1. So theta 1. Okay lah. Okay, so theta 1 will be, it's connected with 2 spring. So you have 40 theta 1 and 2 theta 1 counterclockwise. And then T1 will be clockwise, okay? And then the spring 2 Newton meter per radian also connected with theta 2. So you get 2 theta 2 here. And then the second free body diagram. So on theta 2, you have 1 spring and 1 damper. So this is the effect of spring and damper. And then the spring is connected with theta 1. So you get 2 theta 1. And then the damper is also connected with theta 3. So you get 3 theta 3 dot. And then lastly for theta 3. So it has 2 damper. And then the damper 3 Newton meter second per radian is connected with theta 2. So you get 3 theta 2 dot. Then you can write the equation of motions. And then the question wants you to find theta L over T. So you can use method of substitution. Okay, sama je. So first we transform into frequency response. Okay, so sebelum tadi each free body diagram is 1 mark. Okay. So boleh buat by substitution. Panjangnya. Okay, saya stop kat sini je lah. Okay, so kalau if you guys manage to simplify and then from here you can find theta 3 over T. And then after that you need to convert theta 3 using theta L. So theta L is from here tan theta L, okay? So tan theta L over T. So if you get until here you get 2 marks and then convert into tan theta L, you get another 2 marks, okay? Dan jalan kira tu pandai-pandai lah. Okay, semuanya 10 markah. Alright, so let's move to quiz 6. Okay, sebelum buat quiz 6, kita tengok dulu formula, saya lupa. Okay. Okay, so firstly, we need to determine what is KB and KT over RA. So from the question, it says that the motor develops 50 Newton meter torque at speed 500 Newton, 500 radian per second. So torque equals 50 Newton meter at 500 radian per second. So speed equals 500 radian per second. EA equals 10 volt. And then it stalls out at this voltage with 100 Newton meter of torque. So T stall is 100 Newton meter. So we don't have the omega no load. So what we can do is we can do some apa tu interpolation, okay? So T stall is at omega no load at omega 0, and then at omega 0 T stall is here. And then at about 50 Newton, you get 500 radian per second. So we can do some interpolation here. Macam nak buat ah? Okay, so we can determine the gradient. So gradient is 100 minus 50 divided by 0 minus 500 equals 100 minus 0 divided by so let's say this is omega no load. Oh, dah gila dah. Okay, so this one you get negative 1 over 10. This you get 100 over omega no load. So omega no load equals 1000 radian per second. So here you get 2 marks if you can get omega no load, okay? Whatever way, if you get omega no load equals 1000, you get 2 marks. And then from here you get you can determine KB and KT over RA. So KB equals 10 divided by 1000. 1, you get 1 over 100. And KT over RA is 100 divided by 10. You get 10. Okay, so you get 2 more marks here. And then after that, you need to determine the J equivalent and D equivalent. Okay, so first is the J equivalent. So J equivalent equals, it says here, at the motor is 5 kilogram meter square. So 5 plus the load, which is 100 times 20 over 50 square times 10 over 20 square. So you get 9 kilogram meter square. Okay, one mark here. And then the D equivalent equals 1. So given at the motor it's 1 Newton meter second per radian plus nothing, okay? Because you are not given any damper on the load. And then next thing is you need to transfer theta L. So theta L equals nope, theta M equals apa ni? Theta M equals theta L times N4 over N3 N2 over N1. So you get So you get 5 theta L, okay? So it's one more mark here. Okay, and then you can substitute into the equation. So theta M over EA equals 1 over 9 times RA over KT, which is 1 over 10 S squared, plus 1 over 10 S. So RA over KT, 1 over 10, DE equals 1, plus KB is 1 over 100. So plus 1 over 100 S. And then substitute 5 theta L. So you get 5 theta L over EA. And then theta L over EA, you get 1 over 5 times the transfer function, okay? Okay, so kalau jawapan tak sama, maaflah ya, tak ingat.
Rasa 90 over 100 kan?
90 over 100. Yang ni ke?
Bila isi 100 tu
9.
90. Sebab dia 9 per 10.
9 per 10. Lah. Ayah. Thank you. Okay, ni nanti check lah. Tak tahu betul tak 101 ni. Okay, so kat sini kalau dapat theta M, dapat 2 markah. And then gantikan dapat theta L, another 2 markah. So semua ada 10 markah. Okay, so untuk DC motor ni konsep dia simple je. Maksudnya cari KT over A, cari KB, and then cari J equivalent, damper equivalent, and then just substitute into the equation. So I think if come out in test or final, maybe dia tak bagi formula tu je. Itu je yang susah. Midterm tak keluar kot. Tak apa, tak tengok lagi soalan. Okay, so any question before we move on to the next lecture? Okay, so now we move on to the next lecture on the reduction of multiple subsystem. So your test will come out until this lecture, okay? So kita dah cover sampai week 5. So maybe next week we will try to do some revision before you go to taking your test, okay? Okay, so now we are going into chapter 3, which is the analysis of control system. So before we can do the analysis, we do we go into a subtopic called reduction of multiple subsystem. Okay, so in this lecture, students will be able to reduce the block diagram of multiple subsystem to a single block representing transfer function from input to output. So in chapter 1, back in chapter 1, I've explained about a block diagram that has all the components of a control system. So you have the input, the output, controller, the plant, and you have the feedback loop, which usually contains sensor. So here, maybe the sensor, there are two separate subsystem in the sensor. So you have the feedback and the output transducer, the sensor here. So each of the subsystem in the block diagram usually has its own transfer function. For example, here the input, the transfer function is G1, controller G2, G3, H2, H1, and so on. So meaning that each of them has its own transfer function or equation. And sometimes for control engineer, they know the transfer function for the input, the output, maybe the sensor or the plant. Maybe they don't know the transfer function for the controller. So how they know? Maybe they do some experiment. They obtain a relationship between the input and output, and then they can derive the transfer function. So from there, they develop the block diagram, and then they try to simplify and obtain maybe the actual transfer function. Maybe from there they can obtain the controller as well. So in a feedback control system, usually consists of process and subsystem. So process is the plant, and subsystem are the other things, okay, like input, controller, and sensors. So our objective is to combine all of this block diagram or all of the subsystem here and convert it into a single system only. That's the name of this subtopic, which is reduction of multiple subsystem. So basically, we want to transform this into this one, okay? Only one block, okay? Meaning that we want to simplify this into one transfer function only. So we need to skip. Okay, so before we go into reducing the block diagram, we need to understand the components in the block diagram. So the first component is the signals. So the signals is represented by an arrow, okay? So the arrow, you need to be aware of the direction of the arrow, okay? And then the second one is the subsystem. So the subsystem is represented by the box. with transfer function inside. Okay, so with this box here, the transfer function is GS, and then we have summing junction. So this is the summing junction that I said in chapter 1 or in lecture 1 that you must draw if you have a closed loop system. So you must have a summing junction. So basically summing junction here, it adds all of the signal that comes into the summing junction. So for example here, R1, because it's positive plus, so positive R1 plus R2 minus R3, because R3 goes into negative. Okay, so you get R1 plus R2 minus R3. And then we have peak off point. So peak off point is the point where the signal is split into maybe more than one. Okay, so here RS into 3 here. The signal is split into maybe more than one. Okay, so here RS is split into three more RS here. So after we know the components, then we need to understand the topology or the arrangement of the subsystem in the block diagram. So first we have cascade form. So cascade form, I also call it a series form. So when you when you found a block diagram that is arranged in this way, a signal and then flows into a, a transfer function, and then after that it goes into another transfer function like this, then it is in the form of cascade or series. And then the second one is a parallel form. So parallel form, if you have a signal and then split into two, and then each of them goes into a signal, then this form, we call it a parallel form. And then third one is feedback form. So feedback form is when you have a peak off point here, but one goes back, okay? Another one goes to the front. So one going back, one going to the front, and then the signal comes back to itself. Okay, so here it comes back to itself after it goes back, then it comes back. Okay, then in this form we call it feedback form. Okay, so first we learn how to reduce the subsystem in cascade form. Okay, so when you have a cascade form or cascade arrangement, like for example here G1 and then followed by G2 and then by G3. Okay, ini derivation je. Tak penting. So the final answer is that when you reduce cascade form, basically you multiply all the transfer function in the cascade. Okay. So here, when you simplify the block diagram, you just multiply G1 times G2 times G3. So you get GS over here. Okay. So G1 times G2 times G3. So for cascade, you multiply. Okay. And then the next one is how to reduce subsystem in parallel form. So for parallel form, before you can reduce the subsystem, you need to look at whether the signal splits. Okay, so here it splits into three, and then when it split, it will comes back to a summing junction. Okay, so here the signal RS is split into G1, G2, and G3, and then after that, it will meet back at a summing junction. So when it splits and then meets back at summing junction, then you can reduce in parallel form. So to reduce in parallel form, basically you just add or minus them depending on the signal of the symbol here. So if the symbol is plus, then G1 becomes positive. So if the symbol here minus, then G2 here becomes minus G2. Okay, so that's why here it's plus minus depending on the uh, symbol here. Okay, so parallel form, you just add, okay, add up. So here CS over RS equals plus minus G1 plus minus G2 plus minus G3, okay? So you need to look at the symbol on the summing junction. And then lastly, how to reduce subsystem in feedback form. So for feedback form, you need to look at um, a split here. One of it will go. One of the signal will go backward or forward, and the other one will go backward. Okay. And then the backward one will uh, go into a symbol, and then from the summing junction, it comes back to its original splitting. Okay, pick-off point. So when you have something like this, then you can use feedback form. Okay. So this is the derivation. So for feedback form, basically the simplification becomes GS over 1 minus plus G times H. So the minus plus here basically represent this symbol here. So if the feedback signal goes into the summing junction with a symbol plus, then your simplification becomes minus. Okay. If it goes into a symbol minus, then simplification becomes plus. Okay. So dia terbalik dengan parallel form tadi. So here, if it goes into plus, then it becomes minus. If it goes into minus, then it becomes plus. Okay. So this is feedback. Okay. Feedback ni kena hafal lah. Okay. So it becomes GS divided by 1 minus plus G times H. Okay. Okay, so just now we have looked at three forms how to reduce the subsystem. If you encounter the three forms, series or cascade, parallel, and feedback. Now we look at the arrangement, another arrangement that may exist in the block diagram. First is related with the summing junction here. So the summing junction here, you can move it. If here it's before the block GS, then you can move it after the block GS. Okay, so you can move the summing junction after the block GS, but if you move it to the after block GS, then you need to introduce a block here. Okay, a block at the input here. Okay, so the block contains trans function GS. So if you move the summing junction to be in front of GS, then you need to multiply XS with GS. Okay, meaning that you need to introduce a box here. And then if your summing junction is after the block and then you want to move it before the block, then you need to introduce 1 over GS. Okay. So if you move summing junction uh, from before to after block, then you multiply. If you move it from after to before the block, then you divide. Okay. And then for the peak off point, if you want to move this peak off point from here before the block to here after the block, okay, basically you bring the block here before the peak off point, then each of them must divide by GS. Okay, so here there is a block diagram before, then you divide GS, then it becomes 1 here. Then here no blocks, then you divide by GS, then you introduce 1 over GS. Same for the third one. Okay, and then if you have the peak off point after the block and you want to move it before the block, then you must multiply GS for each of the splitting signals. Okay, so here you have GS, GS, and GS. Okay, multiplied on each of the splitting. So for the peak off point, if you want to move it from before the block to after the block, then you divide. If you want to move it from after the block to before the block, then you multiply. Okay. Okay, so there are so many arrangement. So how to reduce the block diagram? What are the rules to follow? So these are the general rules that you need to follow. Okay, before you can reduce the block diagram. So the first step, the first thing you need to look, kids, that you need to look at the series or cascade arrangement. Simplify cascade or series arrangement first. After that, after you simplify all the series and cascade, then you need to simplify the parallel arrangement. And then after that, simplify the feedback. Okay, any feedback you simplify first. And then if you think that you cannot, if you think that there are no more series, parallel, or feedback, then you need to start shift or move the pick off point or take off point to the right. Okay, always to the right. So shift the takeoff point to the right, and then if you cannot shift any takeoff point, then you shift the summing junction always to the left. Okay, so you can also shift takeoff point to the left and summing junction to the right, but usually it will make the system more complicated. So the general rule says that you shift the takeoff point to the right, always to the right, and shift the summing junction to the left. So the system will be less complicated. But if you move it the other way around, then the system might get more complicated. Okay. And then after step number 5, then you need to repeat the process until your block diagram is simplified. Okay. Okay, so let's look at example how to apply all these rules. Okay. Okay, so let's say you are given a block diagram as shown here. So the first thing that you need to do to simplify this is to look for the series, the cascade. So here, G2 and G3 are in cascade, okay? So meaning that you can simplify them by writing G equals G2 times G3. Okay, so after that, you need to look at the summing junction here. So if you have a summing junction in series like this, basically you can combine them together. Combine means that it will become something like this, okay? Meaning it shares the same summing junction, but the only difference is the symbol they coming with, okay? Like H1 Here it is negative, so here it remains negative. H2 is positive and H3 is negative. So all of them has the same symbol, but the summing junction now becomes only one. Okay. So now here H1, H2, and H3, because it's split from the same peak-off point, and then it meets at the same summing junction, then they become they are in parallel arrangement. Okay, so these two cascade, and then you simplify the cascade, just multiply G2 times G3, and then you simplify the parallel. Okay, so here the summing junction here, it shows negative, so meaning that it factorize the negative. Okay, so here you can write negative H1 plus H2 minus H3, but here it writes negative, so you have to factorize the negative, so it becomes H1 minus H2 plus H3. Okay, so if you write positive here, then you can use this one. If you write negative here, you need to use this one. Okay. Okay. After that, you need to look at this arrangement. There are no more cascade or parallel, and you cannot shift the summing junction. But here, the arrangement is in the feedback form. Okay. So you need to use the feedback form formula. Okay. So this is the formula. So G divided by 1 plus minus H. Okay, so the bottom one is H, the top one is G. Okay, so G divided by 1 plus minus G times H. So it becomes G3, G2 divided by 1 plus G3, G2, and this thing. Okay, so what basically the example did is that it simplifies G2, G3 divided by 1 plus G2, G3, H1 minus H2 plus H3. Okay, after that, this thing becomes a cascade. Okay, so that's why there is a G1 here. Okay, it is cascade with the feedback. Okay, so this is the final reduced block diagram. Okay, let's look at another example. So reduce the multiple subsystem into one system. Okay, so firstly we need to look at the cascade, parallel, and feedback. Is there any cascade? So here there is no cascade and no parallel as well. But we have feedback here at the end here. So you can simplify this, becomes G3 over 1 plus, because it's minus here, so you use plus G3 H3. And then because there are no more feedback, no more cascade, parallel, and feedback, then you need to shift the pick-off point or takeoff point. So the only takeoff point that you can shift is this, and you need to shift it to the right. Okay, so you need to shift it here. So when you shift it there, then it becomes So you need to multiply with 1 over G2 here. Okay, so you shift the pick off point from here to here. Okay, so you get something like this. Okay, so this is the feedback, and then this is the shift of the pick off point. Okay, after that you need to look at you need to repeat the process. Okay, so now you need to look at, is there any cascade? So no cascade. And is there any parallel? So here these are parallel because it splits at the same point and then it returns at the same summing junction. So this one becomes parallel. Okay, so you just add up 1 over G2. So if you have only lines here, only signal, then the signal has transfer function 1. Okay, so you plus 1. Then after you reduce the parallel, then you can remove the summing junction. And then here you can shift the summing junction to the left. So if you shift this summing junction to the left, then you need to divide H2 with G1. Okay, so basically this block G1 here will be moved onto this side. Okay, this signal here, so it will become cascade with G2. Okay, after you move the summing junction, then it becomes cascade G1 with G2. And then after that, these two are in cascade form. And then this thing you can simplify the summing junction. Okay, and then here the two blocks here are in parallel form because it's split at the same peak-off point and then meet at the same summing junction. So it becomes parallel. So you just add up. And then after that, these two are in feedback form. And then you simplify the feedback form. And then the feedback is in cascade with this one. Okay, so these two are cascade. And then you simplify, this is your final transfer function. So in this reduction of block diagram, usually the final answer maybe 1 mark final answer. So you can try to simplify as much as you can, but usually I will tell the student to just leave it as what you can. Okay, if you still trying to simplify it, then it will maybe take up so much time to simplify the block the mathematics. Okay, because maybe it costs only 1 marks or 2 marks. Okay, so the marks mostly goes into the method to reduce the block diagram. So better focus on reducing the block diagram rather than trying to simplify the final answer. Unless if you have a lot of time left, then you can simplify the final answer. Okay, let's look at example number 3. So here you have cascade. Okay, S and S here are in cascade. And then they are in parallel with this one, okay? Because it's it splits at the same peak of point and then meets again at the same summing junction. So it is cascade and parallel. So simplify the cascade parallel first. So you get S squared. So this becomes S squared. And then plus 1 over S, okay? Because the symbol is plus here. Okay, so from here, you have reduced it to this, okay? And then from this arrangement, there are no more cascade, parallel, and feedback. So you need to do some shifting, okay? Shift the peak of point, okay? So you shift this peak of point to the right. So when you shift the peak of point to the right, then you need to add a block 1 divided by 1 over S here. So you get S, okay? And then after that, these two are in cascade. And then at this point, it splits into two signals, one on top and one on the bottom. So S on top and S on the bottom are parallel, okay? Because it split at the same peak of point and then meet at the same summing junction here. So you get this cascade form, and then you just add up S plus S, okay? Becomes 2S because it's parallel. And then these two will become feedback, okay? In feedback form. Okay, simplify the feedback. So you get the final answer here. Okay. Exercise. Apa dah? Okay, let's look at one exercise and then we end the lecture, okay? So reduce the block diagram shown in figure 5.6 to single block diagram. So by finding the trans function Ts Cs over Rs. Okay, so in this arrangement, first you need to look at the cascade. So the only cascade that can be found is here, G6 and G7, because the signal arrow are going forward, okay? So they are meeting in a cascade, okay? And then macam tak ada. So kita try simplifykan dulu. Okay, so after that, this becomes G6, G7. And then the peak of point here, it splits into two, G4 and G6. And then it meets back at the same summing junction. So this here is parallel, okay? So after you cascade, the G6 times G7 is in parallel with G4. Okay, so you just add up G4 plus G6, G7. Okay, so from here, these two are in cascade because the arrow are in the same direction. Okay, so you just multiply multiply them together. And then there are no more cascade feedback, cascade, parallel, and feedback. So you need to shift a peak of point first. Okay, so the peak of point you must shift it from uh, left to right. Okay, so the only way, the only peak of point that you can shift from left to right is this peak of point. Okay, so you need to shift it to the right. So this will become G2 over G5. Okay. When you shift the peak off point, then G5 here will become in cascade with G1. So that's why you get G1 times G5 and G2 over G5. So this becomes the same peak off point. So it's split into two signals and then meet at the same summing junction. Then it becomes parallel. So G2 over G5 plus G3 times G4 plus G6, G7. Okay, they are in parallel. Then you can redraw them first. Then G8 and the bottom one here are in parallel because it's split at the same takeoff point and then meeting at the same summing junction. Then you add up and then G1, G5 will be in feedback with G8 plus this thing, okay? So here is some explanation. So G2, G5 plus G3, G4 times G4 plus G6 times G7 plus G8. So they are all parallel. And then since the forward path transfunction is G1, G5, then it is in feedback. Okay, so they two are in feedback. So you use the feedback formula, simplify it. Okay. Oh, 940 dah. Okay, so there are a lot more exercise in the slide. I think in Kalam as well. So you can study them. Okay. Okay, so your quiz. Ni yang korang nantikan. Okay, so quiz 7A basically simplify the block diagram to obtain CS over RS. Okay. So H1, H2 parallel. And then ni boleh combine good. And then will be feedback with G2. And then these are parallel. Pandai-pandai lah. Okay, quiz 7B. Simplify the block diagram below to find the transfer function CS over RS. So this one is quite tricky because you need to move the summing junction here to the left. But before moving it to the left, you need to look at the direction arrow. So usually you move the peak of the summing junction, let's say from here to here, okay? Meaning that menentang arus, menentang direction or against the direction. But now it's in the direction. You move the summing junction in the direction of the signal. So when it's in the direction of signal, you cannot divide, okay? You cannot divide H2, but instead G4 will multiply with H2, okay? So if you move the summing junction against the direction of signal, then G4 divided by H2. But now it's moving the summing junction in the direction of signal, then you multiply, okay? And then quiz 7C is also tricky. So here, ni bukan pick off point ya. So ni macam dia split macam tu. So this thing, there are no cascade, parallel, or feedback. And if you want to move the pick off point, kalau nak move pick off point ni, you tak boleh move melangkaui over the summing junction. Okay, you can over a block diagram, a block only, or a subsystem only. But now you have a summing junction in the middle, so you cannot move the pick off point over the summing junction. Same thing with this summing junction, this pick off point. If you want to move it to this point, then you need to move it over the summing junction. So you cannot do that. Ni tambahan lah, okay? So you can refer to this website on how to move pick off point over summing junction, okay? Ada cara dia. Okay, so your test will come out until this lecture, okay? Saya belum tengok soalan, nanti dah tengok, saya bagilah clue sikit. So your quiz 7 together with your marks for quiz 5B and 6, you need to submit it on Sunday midnight, okay? Same with your project part 1, okay? So ada soalan? Nak banyak tips, doktor. Apa tu? Okay, after so this Wednesday we will go into the next lecture. Tapi lecture tu saya dah rakam sebelum ni dalam YouTube. Hari tu ada student, tak tahulah, dia orang cakap ada student komplain pensyarah hanya tunjuk video YouTube saja tapi tak mengajar. Jangan komplain saya tau. So Rabu ni I will give you the YouTube video. But that topic is just for understanding only. Maybe it will be beneficial for your project, but usually it is not coming out in your test or final exam. Maybe saya bagi quiz sikit lah kot. Saja nak bagi korang hidup susah. Tu je lah, jangan komplain lah cakap, oh Dr. Jamil ajar guna YouTube je. Okay. So basically this Wednesday tak ada kelas lah, okay? Tengok YouTube video je. So bolehlah sambung tidur sampai tengah hari. Ada orang mencarut tadi. Siapa yang mencarut? Okay, so that's it for today's class. If you have any question, do not hesitate to ask me through WhatsApp, okay? or you can ask me in class. Okay, that's all for today. Assalamualaikum.
Thank you, sir.
Thank you.